So in this lecture I wanted to go through the Oxford blockchain frameworks. The idea of these things is that they provide a rigorous, almost quantitative way of evaluating blockchains, and in particular in determining whether or not a blockchain solution is appropriate for a particular problem. Now these things are qualitative rather than quantitative in nature, and one of the things I wanted to try and show you here is that there is always value in just thinking about these things in logical ways, just using common sense. It's not all about numbers. Now if you go back to fundamentals, one of the important points about blockchain is that there's always a trade-off involved between consensus or truth on the network and speed linked to computational processing. So sometimes the consensus bit is more important, in which case a blockchain solution may be appropriate, though as we will see with the wider Oxford blockchain framework, there are another important considerations to also bear in mind. Sometimes the speed bit is more important, and in this case it's unlikely that a blockchain solution will be best. Okay, so if the consensus bit is the most important bit, then possibly a blockchain solution is appropriate, although there are other considerations. If speed is the important thing, then very definitely a blockchain solution is not appropriate. So in terms of background reading then, using this book published by Shreya in 2020, Basic Blockchain. This is a popular science book, and again this is quite a rare experience for me to be lecturing on a module with potentially such huge popular interest. So it's natural to reflect upon the fact that there is such popular interest in blockchain, but despite that, blockchain isn't necessarily an appropriate solution for all the problems that you might encounter. Okay, so if you recall earlier parts of this lecture course, there's often a trade-off involved in blockchain between consensus and trust on the network and the computer processing power needed in order to achieve that. Now in practical terms, this computer processing power usually translates to the speed involved in processing transactions or information on the network and how fast this has to be in practical terms. So usually the examples that we'll see, consensus or trust on a network would be a good thing. You don't necessarily have the time available in order to have complete consensus on a network. Okay, speed, as with a lot of things in life, is always of the essence. So to try and give an overview of this lecture then, so with these Oxford blockchain frameworks, what I was trying to do here is give you a rigorous, almost quantitative way of thinking about blockchain and related problems. I wanted to try and encourage you to try and think about these things in as practical way as possible, and there is no substitute for logical thinking and common sense here. And indeed, I think one of the things that we will see during this lecture is that much of these Oxford blockchain strategy frameworks are logically constructed and so relatively straightforward. So it's often thought to be easier to understand blockchain and what you're really trying to do by applying these so-called strategy frameworks, and the Oxford blockchain strategy framework helps you to understand if you need a blockchain and where such technology would fit best in the business. Okay, so at risk of repeating myself ad nauseum here, whenever you're looking at blockchain, there's always this trade-off between the level of trust you're able to establish on the network and computer processing power required, which usually translates to the amount of time that the computations will take to run on your network. Sometimes the consensus bit is the most important thing, sometimes the speed is the most important thing. So blockchain always involves a trade-off between consensus and speed, and it should be obvious hopefully that if speed is the most important thing, then not every problem is solvable via blockchain. So a key example of this would be high frequency trading. So this has been important since days where high frequency trading meant relying on carrier pigeon for news of the outcome of the Battle of Trafalgar. Happily, the technology evolved, and this need for speed has on occasion reduced to serious discussions about the length of optic fibre cable involved in order to shave milliseconds off transaction times. So in this environment where time is money, and in terms of time we're talking about fractions of a second, blockchain calculations are too slow to be useful. Now, in other problems, other database structures may be preferable to blockchain. So sometimes if you need a sort of searchable tabular feature in the database or a flat structure, so there's not necessarily fractions of a second involved, but again there's the need for speed, and essentially you can do this in faster ways without blockchain. Okay, so in certain circumstances where speed is of the essence, blockchain is not the thing to go for. So this Oxford Blockchain Strategy Framework sets out a list in almost quantitative terms of when a blockchain solution may be needed to a given problem. So there's 6 conditions that have to be satisfied in order for this to be the case. So the first one is automation, so there should be a certain amount of the problem that can be readily automated or performed by robot essentially. Has to involve a repeatable process and indeed multiple stakeholders. So in both cases there, essentially the thing happens sufficiently many times in order for it to be worthwhile to set up a blockchain solution to the problem. Then there's this issue of reconciliation, so just a sheer need, if you will, to be able to establish trust in a trustless environment. Then this 5th item, value transfer. So again, this is going back to the need to try and establish trust in a trustless environment. And then immutability, so the idea that you can hopefully generate a permanent record of all the transactions information on your system. Now I said there, remember this using this mnemonic ARM RVI. Ignore that really. All I was saying there was that this is something I would naturally ask exam questions on. Different this year, no exam, but I will set something on this on the coursework. So the idea of this Oxford Blockchain Strategy Framework is that each one of these half a dozen things have to be satisfied in order for a blockchain solution to the problem to be warranted. And the first one of these things is automation. So essentially, if you can get to a point where a robot can do everything, then potentially a blockchain solution may be appropriate. So as part of this automation criterion, it's natural to ask, do you have some form of predictability or repeatability in a process that can be automated, so essentially done relatively routinely by a computer? Now in contrast, if regular human interactions are required, then the process is likely to be too difficult to put onto a blockchain. So if you need a organic squishy human being to sort of think about this carefully and you can't automate it, then it is very definitely not a problem that can be solved using a blockchain. But instead, in contrast, if you can get to a point where you can get a robot to do everything, then potentially a blockchain solution to your problem might be appropriate, although there are another set of criteria that have to be satisfied according to the Oxford Blockchain Framework until you can be sure of that. So if you're using this Oxford Blockchain Strategy Framework to decide if a blockchain is needed and the automation criteria is satisfied, the next test is to ask, is this a repeatable process? So essentially what this is asking is, does the thing happen often enough for you to bother building a blockchain solution to fix it? So is the process something that happens frequently, or is the process something that occurs just once? Okay, so the idea here is that a one-time process does not usually justify the expense and operational complexity and everything else, namely the time and cost involved in implementing a blockchain solution. So the basic question here remains, does the thing happen often enough for you to bother building a blockchain solution to fix it? Okay, so this is true with regard to asking if the process is repeatable, but certainly we will see that other aspects of this blockchain framework work in the same way, and in other cases, like when we're looking at multiple stakeholders, the basic question remains, does the thing happen often enough for you to bother building a blockchain solution to fix it? So using this Oxford blockchain strategy framework, if the automation constraint and the repeatable process constraint are both satisfied, then the next thing to ask is about multiple stakeholders. So remember that one of the foundational motivations of blockchain in the context of the Byzantine generals problem was to try and ensure trust in a trustless environment. So in terms of multiple stakeholders, the natural question to ask is, are there multiple parties involved in the process or value chain? Now, if there are, good. If not, then potentially you don't need a blockchain. So if there are only two parties engaged in bilateral negotiations or activities, then there are easier ways than blockchain to achieve your desired outcome. So potentially then, if it's only small scale, you can get away with a squishy, organic, human solution to the problem. Okay, if there's many parties involved, certainly more than two parties, then in contrast, you satisfy this multiple stakeholders constraint and a blockchain solution may be warranted. So again, very similar to the last criteria, what you're basically asking is, does the thing happen often enough for you to bother building a blockchain solution to fix it? So I wanted here to give you a more positive example of where it may be suitable to ask about multiple stakeholders, and in this case it might be a sort of more realistic example and less abstract example. So Shria 2020 gives the example of a group of buyers and sellers who may be trading with each other. So this group of buyers and sellers suggests multiple counterparties, and in a competitive environment there may be concerns about sales agreements being broken. So in financial markets, intermediaries such as exchanges and market makers actually do this process of matching buyers and sellers fairly, but this is a costly thing to set up. And the idea is that eventually, potentially multiple intermediary roles could be ultimately replaced by blockchain. Okay, so what you've got here are problems which I think could become deceptively large very quickly if you've got multiple buyers and sellers and multiple counterparties. And what is going on in these examples is that the thing is essentially happening often enough to justify a blockchain. And probably the thing to have in mind here is multiple combinations of buyers and sellers. So as we said repeatedly then, blockchain involves a fundamental trade-off between consensus on a network and the speed of the computer processing. So in the first bit, if the speed is the important thing, then blockchain isn't the thing to go for. But if the consensus bit is the most important thing, then in contrast, a blockchain solution may be appropriate. So it says here, the feasibility of any blockchain solution may primarily depend on the level of trust involved and also how many parties are involved in the reconciliation. So the thing's got to be important and of a large enough scale. So examples where blockchain may be unnecessary include interactions with a limited number of external auditors and tax consultants. So what you've got here is something that is important but of limited scale. In contrast, as you begin to sort of scale the thing up, then a blockchain solution may become more important. And we'll discuss examples of this later on in the lecture.